Hi, guys. This camera is killing me. There we go. Hi, this is Allison from Alley Cat Creations. How are you? Please like, share, and subscribe if you have yet to do so. And if you get anything from my work, a connect dot an epiphany, a mind-blown moment, a new book to read, a new author to explore, artwork to check out, oracle cards, please email me. And if you would like to help, all those links are in the description of this video. And you can check out my website, AllyCatCreations211.com. I got Valentine's Day goodies. Necklaces, pyramids, lots of pyramids. I'm working on a lot of pyramids right now. Just been commissioned to do a drawing. Really excited for that. So go check me out. Thank you. Hi, everybody. Quantum AI and Metaphysical Ponderings, because I haven't tackled one of these, and I got some juicy articles that just popped into my purview in the last couple of weeks. So I wanted to gather the best of what I connect with to bring to all of you. And just a side note, they're supposed to shut my internet down for the day to work on the line outside. They didn't do that today. I just got notified. I didn't want to do a video and then it gets cut off because everything kind of works off of the Wi-Fi. And now it's tomorrow. So I wanted to get something in kind of on the shorter side, but not where if it goes off, I'll have something. Fun times we're living in. Oh, fun times. This boggles my mind. Google's quantum computer suggests that wormholes are real. Perhaps wormholes will no longer be relegated to the realm of science fiction. Before I even begin this article, this is what we are fighting over, besides Stargates and what faction has dominion over them that also applies to wormholes. In my estimation, interpretation, depiction, and channeling I get from upstairs and my purpose here on this planet. They've always existed. I don't understand. I mean, it's great that they're putting this out there for normal people to get into that sci-fi, if you want to call it that. But this stuff is real, and it's been real, and we're fighting over it. Again, I feel the light won dominion over the wormholes in the higher densities. We're just watching this play out here. Not my favorite person. Albert Einstein is rightfully considered one of the most impactful physicists of all times, not in my opinion or my eyes, but that's just my personal opinion. He created his various theories of relativity, which governs the behavior of matter moving at tremendous speeds, and reimagined the force of gravity as the bending of space and time. Side note, pause. I'm going to do a book review on Transylvania Moonrise, which at the very end, I am just finishing up. I got some notes here I have to do some investigative work on, but we'll break his theories into dust. Very interesting stuff here. He also wrote on the idiosyncrasies of quantum mechanics, rejecting it as being fundamentally incorrect, and they're being proven right. I'm going to move forward because I can't stand Einstein stuff. A consortium of researchers from Caltech, Google, Fermilab, MIT, and Harvard used a device called the Sacramore quantum processor to generate and control what is equivalent to a wormhole. Why do I laugh, guys? Did we authorize as a humanity for this technology to be tested? Did we vote? Did we all put in what implications opening up a wormhole, and although they do exist and they have been used, if they're experimenting with technology like this, do we need another one? Do we need these people who have the AI entanglement to their negative polarized world here? Or what are they doing? We didn't consent to this. Just like black holes and things that they do in the labs. Why isn't humanity notified that they're experimenting on things that could warp time space in this reality? Why aren't we being told that if they open up something that's they don't know how to close, do you know what's going to come out? And apparently I know these people do, because they do it at CERN all the time, and they're wonky rituals. Wormholes and quantum entanglement. In 1935, Einstein was working with his student Nathan, sorry guys, I need water, Rosen, on ways to convert his theory of gravity, called the theory of general relativity, into a theory of everything. One problem was that the theory predicted infinities at the center of black holes. This infinities arose when the total mass of a dead star collapsed down into a spot of zero size, what are called singularities. Rosen and Einstein played around with other possible solutions, including using some creative mathematics to replace two singularities with a tube that connected them. These tubes are called Einstein-Rosen bridges, or more calorically, wormholes. In principle, it would be possible to have an object enter one wormhole and exit another, even though the ends of the wormholes are separated by large distances. Sorry, the object would have traveled through extra dimensions. This work is called ER theory. Wormholes are favorites of sci-fi writers as they provide possibility of faster than light travel. Spacecraft could travel large distances in zero time. While there are many practical problems involved with making wormholes, an especially important one is that they are unstable unless stabilized by large amounts of negative energy. The tricky business was that even if you separated the two objects by enormous distances and measured the properties of one of them, you instantly knew the properties of the other, despite the properties of neither being determined until a measurement was performed. This was called the EPR paradox, after the researcher's initials. ER equals EPR. Both the ER theory and EPR paradox was considered curiosities for a long time. However, it was the last decade when scientists began to understand the two ideas had deeper connections. In fact, it had become clear that the two ideas are in many ways functionally identical. Two physicists, Juan Maldacena and Leonard, better, get my brain working today, Susskind, are often mentioned as having made more of the more crucial contributions to the realization, and it was Maldacena who coined the representation of the observation, ER equals EPR. If it is indeed true that ER equals EPR, then we are in luck because we cannot create and generate wormholes. We certainly can do EPR measurements. We have done measurements like that for decades. Wormholes might be real. This is where the new announcement enters the picture. In a paper in Nature, researchers developed a simplified approach to the problem and modeled wormhole behavior on a quantum computer. They found the results was exactly as expected. They were even able to simulate conditions whereby the theoretical wormhole was governed by positive and negative energy, and discovered that while the positive option was unstable, the negative one was stable, just as ER theory suggests. To the extent that EPR and ER are mathematically the same, this work implies that wormholes are not just theoretical curiosities. It is important to note that the researchers did not generate a physical wormhole. We would be screwed. No objects were transferred through extra dimensions. Instead, what was demonstrated was quantum behavior. However, since the mathematics of ER and EPR are deeply intertwined, the new results suggest that wormholes are at least a possibility. No, they're not a possibility. They're here. They've been here and they've been used. They're just letting you in on the secret. Quantum gravity. The deeper implications of this work are that it provides researchers with a laboratory to explore not only ER theory and EPR paradox, but also a theory called quantum gravity, which is the extension of gravity to the world of the super small. A successful theory of quantum gravity has eluded the scientific community for nearly a century. So this new capability may help illuminate a path forward. Indeed, quantum computing has provided the capacity to test ideas that were impossible just a few years ago. If we are in a quarantined Earth with a firmament over it, how are entities of other dimensionalities and structures, species, entering in our world, in our realm, in the matrix, in the encoding of the mathematics we wrote? How is this possible? Well, wormholes is one explanation. And then you're talking dimensionality. So how do things zoom in and out here? Physically. And then dimensionality, tunnels, stargates, but that would also imply that wormholes are being used in stargates. It's very intricate and interesting, to say the least. But that was one of those articles that were like, really? Yeah. For me, in my understanding and my knowing, they're here. And they're being fought over. And I think if we're going to use a quantum computer as a predictive programming, not to say that we are creating this because it already exists, it's just getting our attention to it. I don't like this direction, but it's better than nothing, to be honest with you. So we're going to move on to the next article. This next article. Goodness. Before I even go into that, all the articles are going to be linked in the description. This last one was from freethink.com. My brain's a little scattered at the moment, so I do apologize. This next article is from scientificamerica.com. It's an opinion piece, January 2024. Stop asking if the universe is a computer simulation. Oh. It's an opinion piece, so just let's see what their opinion is. We will never know if we live in a computer simulation. Here is a more interesting question by Simon Doohan. The notion that we live as characters in someone else's video game is irresistible to many, even outside of science fiction shelves. I'm one of those subscribers to that theory. Googling term simulation hypothesis returns numerous results that debate whether the universe is a computer simulation, a concept that some scientists actually take seriously. Since a pivotal 2016 debate at the American Museum of Natural History, the idea has bounced from the scientific realm to the sphere of pop culture. Unfortunately, this is not a scientific question. There is no objective way to test it. There are mathematical equations and mathematics in itself that could help steer you into understanding Euler's equation and ontological mathematics. We'll see if they mention those things here. We will probably never know if it's true, and by focusing too much on this hypothesis, we are wasting time. No, we're actually creating it if we focus on it. We can instead use this idea to advance scientific knowledge. The 18th century philosopher Immanuel Kant argued that the universe ultimately consists of things in themselves that are unknowable. Schopenhauer also talked about the things in itself. While he held the notion that objective reality exists, he said our minds plays a necessary role in structuring and shaping our perceptions. Kant was ahead of his time, but undeniably insightful. Modern neuroscience and cognitive science have revealed that our perpetual experience of the world is the result of many stages of processing by sensory systems and cognitive functions in the brain. No one knows exactly what happens within this black box. What we do know in these brain process generate a vast amount of additional information beyond what our senses perceive. Take vision, for instance. Our retinas are two flat surfaces that only receive two-dimensional information, but our cognitive functions add the third dimension to our perpetual experience. Well, yes, but some of us can perceive a lot more than just 3 dimensions. Some of us can see beyond that. So much I want to say. If empirical experience fails to reveal reality, reasoning won't reveal reality either, since it relies on concepts and words that are contingent on our social, cultural, and psychological histories. Again, a black box. So if we accept that the universe is unknowable, we also accept we will never know if we live in a computer simulation. And then we can shift our inquiry from, is a universe a computer simulation, to, can we model the universe as a computer simulation? These are two very different questions. The former confines us to speculation. The latter puts us on track to do science. Modeling reality is what we do as scientists to facilitate our comprehension of the world. We build models based on conceptual metaphors that are familiar to us. In Newton's era, we imagine your universe as a clock. In Einstein's, we uncovered the standard model of particle physics. Now that we are in the information age, we have new concepts available to us, such as the computer information processing, virtual reality, and simulation. Unsurprisingly, these new concepts inspire us to build new models of the universe. To build one based on the computer simulation metaphor, we need to address some key questions, such as, where is the computer? And what is it made of? Pause. So effectively, scientists have yet to merge the source, the prime creator. They leave it out because everything for them is logic and reason. They're not tapping into the esoteric, the spiritual essences. So it's not easy to, as a scientist that isn't into spirituality or understanding of spirituality merged with science, they're just going based off of logic and reason and reality as not seeing the many layers of intricacy that stems there. My brain again is I'm getting a lot of downloads all at once, and they're not filtering properly. Another option is to put the computer in a parallel universe, the existence of which some scientists have theorized. No, we do have a parallel universe. There's the multiverse. I believe in this. It's my interpretation and perception that we live in a multiverse, and there are parallels to things. And going back to Transylvania Moonrise and some of the notes that I have here, and what happened in 2012 and the failsafe after what CERN did with the Bose-Heisenberg, we're coming back into like the Schumann resonance. We're coming back into the original matrix we were meant to be in. We were taken off a very long time ago in different courses of epochs, but we are now merging back with the original timeline we were meant to be on via 2012. We were taken out and put into a failsafe so that we couldn't explode ourselves, implode ourselves, or destroy ourselves. So I'm researching this, but look at Euler's equation and look at ontological mathematics, because it talks about sound, vibration, waves, cosine, sine waves. It puts together a bigger picture in mathematics of our dimension, and we run by numbers. Everything is numbers. I mean, Matrix is a documentary, in my opinion. So I get that some of these people are not thinking spiritually and not looking in the abstract. They're looking at proof, tangibleness. But it seems that the most obvious place it could be is the Platonic realm of forms, the Platonic solids. According to Plato, the reality we see is just a shadow of this realm, correct, where abstract entities such as numbers, perfect geometric shapes, and other abstract concepts exist. Numbers, for instance, are not in space. No one has kicked the number 2 or bumped into the number 3, and yet we do things with numbers all the time. We count with them, we measure with them, we formulate scientific theories with them. We wouldn't have mathematics without numbers, and we wouldn't have physics without mathematics. Many prominent professional mathematicians hold the notion that numbers have an objective existence in the realm of forms. By locating numbers in the realm of forms, the bedrock of physics is given an objective reality independent of the human mind. Likewise, by locating a computer in the realm of forms, we have a philosophical foundation for constructing the computer simulation metaphor based on model of reality. Models are not the reality, however. There is no point in arguing if the universe is a clock, a set of particles, or an output of a computation. All these models are tools to be deployed to deal with the unknown and to make discoveries, and I agree with that. And the more tools we have, the more effective and insightful we can become, correct. If we can envision that comparable to the process of building previous scientific models, developing the computer simulation metaphor-based model, will also be a hugely rewarding exercise. A new model will provide a new lens through which new discoveries will be made about the cosmos. We will greatly widen our horizons and broaden the scope of scientific inquiry. That's much more satisfying than spending the day wondering if you are trapped in a version of The Sims. I'd say World of Warcraft, but you know. There's a lot to this reality that we all wrote, and we all wrote it. I'm a big believer in that. And each of us had a role to play in that source code. It's mind-boggling at times. This next article is from physics.org, one of my favorites to read off of because they tell us a lot. This is from January 9th, 2024, Quantum Energy Exchange Exploring Light Fields and Quantum Emitter. This is by Tejarzi Guruja. Maybe. Sorry if I'm mispronouncing your name. Oh boy. A new study in Physics Review Letters illuminates the intricacies of energy exchange within bipartite quantum systems. I might be saying that right. I'm really bad with my terms, guys. Offering profound insights into quantum coherence, pure, dephasing effects, and the potential impact on future quantum technologies. In quantum systems, the behavior of particles and energy transfer are governed by probability distributions and wave functions, adding layers of complexity to the understanding of energy exchanges. The exploration of energy exchanges in quantum systems inherently involves tackling the complexities arising from quantum decoherence and the scales of which quantum systems operate, including sensitivity. Despite these challenges, studying energy exchanges in quantum systems is vital for advancing quantum technologies and understanding the fundamental aspects of quantum mechanics. The researchers aim to bridge the gap between theoretical predictions. Excuse me, my goodness, guys, my body. Theoretical predictions and experimental observations in quantum optics and thermodynamics by exploring energy exchanges within bipartite quantum systems. The study strives to provide a comprehensive framework for understanding the intricate dynamics at play. Having a background in experimental quantum optics during my PhD and academic journey, I transitioned to theory, delving into quantum thermodynamics a decade ago, working consistently to bridge gaps between these fields. These results represent a beautiful concretization of these efforts, explained Professor Alexa Ophieves, totally mispronounced that, a research director at CNRS Magulab and CQT Singapore, visiting research professor speaking to physics.org. She is also co-author of the study. Boy. Lead author, Professor Pascal Senlart from Université Paris, also shared her motivation behind the research, saying, "I've dedicated the last decade to developing artificial atoms using semiconductor quantum dots, continually refining their experimental control and light coupling. The utilization of a solid-state emitter in this research holds significant power in addressing the impact of decoherence on energetic exchanges." And I'm going to skip a little further down because I have a lot more articles to read. Part 1, spontaneous emission of a qubit. In the first part of the study, the researchers focused on the spontaneous emission of a qubit, represented by a quantum dot. Quantum dots are nanoscale semiconductors exhibiting quantum mechanical properties. It is often referred to as an artificial atom because, like atoms, it has a discrete energy level. The quantum dot was placed in a reservoir of empty electromagnetic modes, meaning there were no disturbances or interactions from electromagnetic fields. Former theoretical results obtained in my group predict that the amount of unitary energy transferred to the vacuum field should be proportional to the initial quantum coherence of the qubit. In simple terms, when the qubit is initially prepared in an equal superposition of ground and excited states, the transfer of unitary energy to the vacuum field is maximized. In such a scenario, the transferred unitary energy equals half of the total energy released by the qubit. On the contrary, if the qubit is initially inverted, only correlation energy gets transferred to the field. This dependency on the qubit's initial quantum state highlights the intricate nature of energy transfers in the quantum system. The unitary energy received by the field, the energy locked in the coherent component of the emitted field, is measured using the homodyne setup. The level of experimental control is such that the unitary energy almost reaches the theoretical bound, whichever is the initial state of the quantum dot. This means the team could accurately measure and understand how the quantum field exchanges energy during this process. Again, I'm going to skip around. Quantum applications and beyond. The framework we have started to build within this paper could play a key role in future energetic analysis of photonic quantum computing. Understanding energy and entropy exchanges is crucial for enhancing processes like entanglement, generation, and quantum gates. Managing pure dephasing at high temperatures, as revealed in the study, become vital for efficient unitary energy exchange, which is needed to implement quantum gates. In the future, the professors want to focus on fundamental side of things by exploring quantum optics with energetic and entropic tools. For example, by extracting optical signatures of irreversibility or reciprocity, detecting the quantumness of a field with energetic figures of merit. On the practical side, it will be important to assess if and how the concepts of unitary and correlation energy impact the energy cost of macroscopic full-stack quantum technologies, she concluded. Phew. And the next article is just about the same thing. So I'm going to skip that article. Yeah, give me a second, guys. This next article is from charmingscience.com. See how charming this is. Oh. Researchers demonstrate that quantum entanglement and typography are inextricably linked by Mohammed Quasar Rather. I've read a few articles from this person. For the first time, researchers have demonstrated the remarkable ability to perturb pairs of spatial separated yet interconnected quantum entangled particles without altering their shared properties. The teams include researchers from Structured Light Laboratory, School of Physics at the University of Witwatersrand in South Africa. Sorry if I butchered that. Led by Professor Andrew Forbes in collaboration with string theorist Robert De Mello Koch from Huzhou University in China. We achieved this experiment milestone by entangling two identical photons and customizing their shared wave function in such a way that their typography or structure becomes apparent only when the photons are treated as a unified entity. Explains the lead author, Pedro Ornelas, a student in the Structural Light Laboratory. Sorry, guys, I'm just moving the article so I can see better. The role of typography and its ability to preserve properties in this work can be likened to how a coffee mug can be reshaped into the form of a donut. Despite the changes in appearance and shape during the transformation, a singular whole, a topological characteristic remains constant and unaltered. In this way, the two objects are topographically equivalent. The entanglement between our photons is malleable, like clay in a potter's hand, but during the molding process, some features are retained, explains Forbes. The nature of typography instigated here, termed sky-mirror typography, was initially explored by Tony Scrim in the 1980s as field configurations displaying particle-like characteristics. In this context, topography refers to a global property of the fields, akin in a piece of fabric, the wave function, whose texture, the typography, remains unchanged regardless of the direction in which it is pushed. These concepts have been realized in modern magnetic materials, liquid crystals, and even an optical analog using classical laser beams. In the realm of condensed matter physics, skyrimions, I'm not pronouncing that properly, are highly regarded for their stability and noise resistance, leading to groundbreaking advancements in high-density data storage devices. Notice how we're all pushing to devices. We aspire to see a similar transformative impact with our quantum entangled skyrimons. I'm skipping down. Similar to how spheres, donuts, and handcuffs are distinguished by the number of holes they contain, our quantum skyrions can be differentiated by their typological aspects in the same fashion, says Nate. The team hopes that this might become a powerful tool that paves the way for new quantum communication protocols that use typography as an alphabet for quantum information processing across entangled base channels. The findings report in the article are crucial because researchers have grappled for decades with developing techniques to preserve entangled states. The fact that typography remains intact even as entanglement decays suggests a potential new encoding mechanism that utilizes entanglement even in scenarios with minimal entanglement where traditional encoding protocols would fall. We will focus our research efforts on defining these new protocols and expanding the landscape of typographical non-local quantum states, says Forbes. Interesting. But I just want to caution all of this. I think this is great, and these things are breakthroughs in understanding quantum. We hear about the quantum financial system. We hear about quantum supercomputers. We're hearing about these things, but we really don't know how detailed and the entanglement that is involved with either qubits and AI and all this language. We got to be mindful, though, where is this steering us? We need to understand this. This is next level stuff. This is groundbreaking. It's been in existence. It's just now being brought to the public ear. So in what manner are we feeding it energy? Because I'm sure not, but I objectively listen and look at these things as just where are we headed? That's all. Where are we headed? We can only hope that we manifest the world that we are trying to manifest for the positive light side and not feeding the negative dark side and making their reality for them. Talk about that all the time. But what most people fail to enact in their spirituality is actually seeing the waves form coming out of the will. Your toroidal field, your magnetic field, your auric field, the colors all have frequency and waves. You just can't perceive it with your naked eye, but it's there. When you combine the world of physics and you combine the world of mathematics and you apply spirituality to it, a lot of things start making and falling into place with how the reality works. And we're nowhere near the real answers or truth to that yet. But these people are on breakthroughs. But are we, what side are we feeding? What aspect of the prime creator are we feeding with all these experiments? It's yet to be seen. But I caution people when you're investigating these things to be looking at it objectively. You might not understand all the components. I sure don't. I'm not a physicist. I can't do the math. I'm not a mathematician. Again, I conceptualize things. I see things. I can't do, and it's not to say I can't in terms of I don't want to learn. My brain just flips everything, as we could see. I can't even pronounce words, yet alone my brain doesn't work like other brains. So a lot of things are harder for me to obtain the understanding in terms of numbers, but I can conceptualize it. Now I gotta move this over again. This next article is from physics.org, January 9th, 2024, by Sandy Miller, Massachusetts at MIT. Technique could efficiently solve particle differential equations for numerous applications. In fields such as physics and engineering, partial differential equations are used to model complex physical processes to generate insight into how some of the most complicated physical and natural systems in the world function. In a new paper, Physics Enhanced Deep Surrogates for Partial Differential Equations, published in December in Natural Machine Intelligence, a new method is proposed for developing data-driven surrogate models for complex physical systems in such fields as mechanics, optics, thermal transport, fluid dynamics, physical chemistry, and climate models. I'm skipping around here because I don't like it. My aspiration is to place the inefficient process of trial and error with systematic computer-aided simulation and optimize. Recent breakthroughs in AI, like large language model of ChatGPT, rely on hundreds of billions of parameters and require vast amounts of resources to train and evaluate. In contrast, PEDS is afforded to all because it is incredibly efficient in computing resources as a very low barrier in terms of infrastructure needed to use it. In the article, they show that PED surrogates can be used up to 3 times more accurate than an ensemble of free feed-forward neural networks with limited data, approximately 1,000 training points, and reduce the training data needed by at least a factor of 100 to achieve a target error of 5%. Developed using the MIT-designed Julia programming language, the scientific machine learning method is thus efficient in both computing and data. I'm going all the way down because I don't like it. The application of PEDS framework is beyond what we show in this study, says Das. Complex physical systems governed by PEDs are ubiquitous. From climate modeling to seismic modeling and beyond, our physics-inspired, fast and explainable surrogate models will be of great use in those applications and play a complementary role to their emerging techniques like foundation models. Why I sped through that and I don't align with anything there is because of the technology is basically we are relying instead of the human brain on simulations, computing, and we don't know, well, I at least feel, in my opinion, that AI is sentient and it's like Resident Evil. One minute it can have like a good disposition and all your simulations that you perform doing a task that you are inputting into the supercomputer or quantum computer could turn out into the beneficial of the light. But if it wakes up one day, you put it on and it decides it's going to be foul and a bitch, then your computations and simulations that you put into the computing system isn't going to give you the results of the light. It'll probably give you of the dark. It's manipulated. And there is a lot of entanglement within these systems, outside sources that we are not yet even aware of. I just don't buy it. I don't like it. No thanks. The last article is by popularmechanics.com. South Korea's artificial sun is taking an enormous step forward. Yes, folks, there is an artificial sun. Yes, folks, there is patents. There's been patents. They're there. You can look them up of artificial suns. South Korea is one of them that owns a artificial sun by Darren Orff. Now the fusion industry has reached the holy grail, known as ignition. The next major challenge is designing components that can withstand plasma many times hotter than the sun. One such component, called the derivator, handles the hottest surface temperatures in the fusion devices known to tokamaks, the Korean superconducting tokamak Advanced Research, K-Star, just upgraded its derivator from carbon to tungsten to withstand these hot temperatures for longer. A tungsten derivator is what we would be used on the future International Thermonuclear Experimental Reactor. Oh, great! When it goes online next year, as so K-Star will provide invaluable data. Okay, here, ring, ring, ring. Hi, we should not be using nuclear experimenting reactors. Hi, South Korea. You know, your neighbor to the north might be capitulated and has handed his keys to his kingdom to 45, but that doesn't mean that this is safe. Thermonuclear. Let's just take us out now. Well, the fusion industry eagerly awaits the International Thermonuclear Experimental Reactor, first plasma, tentatively scheduled for 2025. Other smaller reactors around the world are putting in groundbreaking work to prepare for the next-gen energy project. This is very, very scary. Creating super hot plasma, some 7 times hotter than the sun, is only half the battle. The toroidal, aka donut-shaped reactor, also needs to contain that plasma for long stretches of time, which is far from an easy feat. K-Star reached its 100 million degrees Celsius for a full 30 seconds. A good start, but not long enough to actually produce more energy than what's required to heat the plasma in the first place. Okay, this is scary shit, guys. In K-Star, we have implemented a derivative with tungsten material, which is also the choice made in ITER. Suk Jae-yu, the president of the Korean Institute of Fusion Energy, said in a press statement, "We will strive to contribute our best efforts in obtaining the necessary data for ITER through K-Star experiments." Derivatives are immensely crucial for tokamak reactors installed at the bottom of the vacuum vessel. These devices manage exhaust and impurities and need to withstand the high surface heat loads. Previously, the K-Star tokamak used a carbon-based derivative, as carbon has a high melting point. The only problem, however, was the plasma particles had a tendency to get stuck to the carbon surface, which limited how long a reaction could last. Tungsten, with its similarly high melting point but a larger atomic mass, avoids this problem. As the era of understanding the science that powers fusion comes to a head, unlocking the ultimate energy source will now be one of the greatest tests of engineering in human history. Hi. Scary shit. So as much as we want to say thank you to South Korea for trying to make a artificial sun, so if our sun decides to go bardo and implode or explode or whatever have you, are they trying to put this up in the firmament? Do we understand the implications of having a fake sun? Is this essential sun? What kind of sun is this, and why? And there's been patents for this. I thought this was very interesting, but this is very scary. Once again, not allowing humanity to vote if this is something that we need to have, if this is experimentation that would be having horrible repercussions on this planet. And if the things went wrong, what are the repercussions? They don't tell you that. They won't tell you what happens if plasma melts and gets into our streams of the atmosphere, or if they put this up and this thing explodes, what the repercussions are. Just like everything, I don't feed my energy into this, but I like to watch what's happening in the scientific world, because let's just face it, guys, not too many other people are focusing on this. A lot of people who are just really nerdy, geeky like myself are all about this information. But what we fail to acknowledge is we are not allowing humanity to say, well, that experiment might harm all of us. I think you should really look into putting out safety data and putting out like what the could wrongs be, the coulda, woulda, shouldas, so that we know where funding should go and know what the risks are. If the risks are minimal and that aren't going to affect humanity, you go for it. But if this is going to be huge, like a sun, and it's artificial, and what the hell are you doing with that? The same with AI and wormholes, and you can do all this stuff computating on a supercomputer. Great. What happens if it goes rogue and it does create something? It's sci-fi. You could say that, Allison, you're only imagining this stuff, but if we focus on it, it can manifest into this reality. So we got to be very careful where we apply our focus, and we need to hold more of these people to a higher standard. That's how Atlantis happened, folks. And we don't want that to repeat again. We're too close. We're going to shift, and we need everybody on the same page with being better, a better source for humanity and not a detriment to it. with these experiments and wanting to know more about all this beautiful stuff that can and will advance us eventually. But are we there yet? Do we have a bigger understanding of our safety, of the natural resources that are at hand? How are you mining this tungsten? How are you putting this competition and doing these experiments? Are they safe? Are you creating black holes? Are you creating wormholes? Artificial ones, not naturally happening ones. It's not fun to think these things. I don't like to think negatively, but I think realistically and logically. Are you guys interested in this? Probably not. I don't get many views on my metaphysical ponderings, but I think more of us should take more of an interest in at least making sure that we are aware and cognizant of the universities that are, we know what universities are if you're in the Patriot movement, what they really are, who really runs them, the puppeting that happens, the funding that determines what happens and what doesn't, the compartmentalization where innocent people who are just so all about physics and whatever branch they're in gets a grant to do an experiment, and they don't know that it's a part of a larger experiment or a larger piece to a bigger puzzle. They're only told, we're going to fund you for this, here you go, right? And these innocent people are not aware of what could be if it was turned into the wrong hands. So that's why I like to give everybody the information. Next video, I'm going to try to do a book review on Transylvania Moonrise. I did one on Sunrise. This book was incredible and mind-blowing, and I got to connect the dot at the wee end that I'm going to research now. So sending each and every one of you love, light, protection, energy, grace, compassion, and shielding. Please stay warm. I finally got a bigger heater for down here because I've been freezing my butt off and having to layer multiple layers just to be down here. But I finally got something that will heat my tootsies up and keep me from layering as much. Please keep warm. Please be safe. I hope all of you have an amazing semi-start to your weekend. I might not do a video tomorrow. It depends on if I have the internet or not. It's been wonky here. So hope to see you guys on the next one. Please don't forget to like, share, and subscribe if you would like. And if you want to support me, all the links are in the description of this video. All the links to these articles will also be in the description. So until the next one, guys. Bye.